So welcome everybody to the 43rd episode of GoingNative. Steve, what do we have?
All right, so last month when we had 800 great C++ visitors here in Bellevue for CppCon, we actually interviewed a bunch of the speakers and asked them to give sort of the elevator pitch for their talks. In the time since then, it's been about 3 or 4 weeks since CppCon. All of those talks are now up on YouTube for you to go and watch. So this episode should act as a sort of table of contents to some of the interesting talks that you can go watch on YouTube. I've been enjoying them for the last few weeks. There's a lot of great content out there, and hopefully you'll find something interesting. This one's a little bit longer than our normal episodes because we did interview quite a few people, and there's a lot of diversity in the types of talks that you can go and find. So on with the interviews. Welcome, Channel 9 viewers. I'm here today with Jon Kalb. Jon, do you want to introduce yourself?
I'm Jon Kalb. I'm the chairman of CppCon, and I'm really excited about what we're going to see this week.
All right, can you tell me a little bit about the conference?
Well, this is our second year.
Awesome.
And we run 6 tracks, 5 days. So we'll have about 100 sessions, about an hour apiece. And we'll be recording them all and putting them online for everybody to enjoy. But there are some sessions that are not online, and probably the most important is the hallway track. The conversations that happen between developers when they get excited about a talk they've seen and want to share that.
Yeah, don't forget, you can enjoy all these videos, but next year you want to come out, to sunny Bellevue, Washington, and enjoy the conference in person. All right, great. But you're not just the conference chair. You're also a speaker this year, right?
That's right. I'm going to be speaking on, it's called C++ Today, The Beast is Back.
All right.
So I have a book about that. And basically, we're talking about why people would use C++, why its popularity, in the 80s and 90s with the object-oriented programming hype, and it was very popular. But then in the 2000s, it kind of got pushed aside by the Java hype machine.
That's right.
And but in the last 5 years, there's some technical things and some other factors that have caused people to be much more interested in C++. And so that's what the talk is about.
I read the book, and it was awesome. Yeah. So can you talk about those factors a little bit? Like, what are the things that are driving people back to C++?
Well, I think the two biggest, there's some other things too, and we talk about that in the talk. But the two biggest are technology. It used to be that the thinking was, well, C++ is a challenging environment, Java's easier, and the big trade-off is you don't have as much performance with Java, but who cares? We have these machines, Intel's giving us these really powerful processors, and who cares if your desktop machine is slightly slower? It doesn't matter. Right. But now, that's not where people are concerned anymore. Now we're talking about mobile devices, right? Or cloud. But in both cases, either you're looking at battery power or you're looking at the cost of powering up the
milliwatts or megawatts.
That's right. It's one of the two. And so performance per watt is what it's all about. And so now we're looking at C++. The other big thing is that with C++ 11 coming out, people are now looking and saying, wow, this is a whole refresh on the language. It feels like a new language. It's much more modern. It has some of the things that we've wanted for a while. So those are the two biggest things. There have been some other things too, and like I say, we'll explore that. We talk about it in the book, and we'll explore it in the talk. But those are the big drivers.
All right, so check out the book, and then check out the talk.
Right.
Great. All right, thanks, Jon.
All right, thank you very much.
I'm Sean Parent. I'm a principal scientist at Adobe Systems. I've been there about 20 years now.
Cool. And what's your talk this year at CppCon?
So my talk is about data structures. Each of my talks recently has a goal with it. So the goal with this talk is no incidental data structures. So in the talk I explain what an incidental data structure is and how you avoid them.
Okay. What is an incidental data structure?
Well, for that you have to watch the whole talk. You're giving away too much information. But the basic idea is you want to enable local reasoning within your application. So how do you avoid creating convoluted structures within your code where you can't just look at a single function and figure out what's going on?
Got it. So it's basically applicable to all developers who write, if you use data structures.
If you use data structures, right, or algorithms, then it's applicable to you. Yeah.
Thank you, Sean.
Yeah, thank you.
Michael, can you introduce yourself to the Channel 9 audience?
Hi, my name is Michael Wong. I am the senior technical lead for IBM compilers, as well as the CEO of OpenMP, as well as the chair of a couple of study groups, SG14 for games development and low latency, and SG5 for transactional memory.
Okay, great. So I think you got a couple of different activities that you're doing at CppCon this year.
Yeah.
Do you want to tell me a little bit about your atomics talk?
Sure. Probably one of the most mysterious but most hidden aspects of the new C++ 11, 14, and 17 is the memory model, which safeguards, which is essentially a contract between the language and the users and the compiler implementers about what is safe and what can be done concurrently.
Okay.
Yet it's probably one of the most mysterious and most complex aspects and rarely talked about in some ways. So in a way, I'm trying to take on the challenge of trying to explain this to people since I was involved with its original inception almost back in 2005. So I'm hoping that, so this is part one of two parts. It's almost too much to talk about in 1 hour. So I'm going to talk about 5 of the 6 memory models, and then Paul McKinney, who is a distinguished engineer at IBM, is going to talk about the 6th, the consume. The consume is actually almost too complex even for me, so I'm going to relegate that to someone else.
Got it. You subcontracted the job.
Yes, I know where my limit has been reached.
Okay, great. So people who are interested in memory models should definitely check that one out.
Who's interested? Surprisingly, the memory model and the atomics and how atomic operations use the memory model is of vast interest to games programmers. People who are in the finance, trading industry who wants to squeeze the latest performance out of C++, and yet keeping it portable. You see, prior to this, people were writing it using platform specifics,
libraries
and APIs and instructions, built-in functions, and these were not portable. Whereas here, what we did was we developed a model which is portable, but still gives you a vast majority of the performance. Of course, if you want your very last drop, you still probably have to get away from that. But yeah, this is pretty good as it is.
That's great. And you mentioned game developers, and I think that's the second thing that you're here to do, right? You want to talk about SG14?
Absolutely. I'm really excited about SG14. It's a new study group that we brought together in the last meeting after I've been engaging with them since the last CppCon, actually. It was in the last CppCon that the games developers and I kind of got together into an impromptu BOF, and we decided that we really wanted to do something to help improve C++. So I was in conversation with them for much of October, November, December, January this year, and we put together a proposal, and surprisingly, I'm sometimes surprised when things succeed.
Yeah, when things are meant to happen, they just happen fast.
We got we got strong support at the standard meeting in Lenexa. People said, yeah, we want this, we want to form a study group. And by the way, can you also include low latency and finance and trading and things like that into it, so that it covers an area that C++, number one, C++ has always been well used in games and in finance and trading. And number two, this is an area that people have been asking about certain improvements on. But sometimes because they can't easily attend standard meetings like we do, they can't bring those forward. So this is a way to do it. So we encourage anyone who's interested in low latency applications, soft real-time graphics, to come forward. Among the discussion topics we're going to look at are things like how to control exceptions and RTTI. It's one of those areas where C++ kind of violates itself, even though it says there's no cost and you don't use it. Well, there is a cost
to
these things.
It's an abstraction with maybe just
a little bit of cost.
Cost.
So we can't promise we'll remove it because that's obviously something very complicated. But we're looking at various alternatives. Other things we're looking at are things like better library supports to enable a more flat mapping of the memory, as well as possible GPU accelerator supports using coroutines for games. And I'm also putting a call out to anybody who has a deep interest in financial and trading applications who have low latency needs to come to our group and join us because we need your help.
So after the conference, how should people who want to get involved in that contact you?
A couple of ways. The easiest way, believe it or not, is actually just to Google SG14 ISO CPP. That will almost always easily get you into the Reflector group.
Okay.
And you'll see what's going on there. You'll see my email. You can contact me personally. My name is obviously all over slides and wherever and all that stuff.
Great.
So you can always contact me at IBM in my Gmail or through SG14. And I definitely will respond to you so that we can get together and see if we can move C++ ahead for the benefits of this group.
Sounds great.
All right.
Thanks for taking
Hey, thank you very much. It's always fun to be here.
All right.
Thank you.
Thank you. I'm here with Nick Lazareff today. Why don't you introduce yourself for us?
Like you said, I'm Nick Lazareff. I'm a VR engineer working at a company called Otoy. Specializes in rendering and graphics, special effects for the movie industry, games, and anyone else that uses rendering technology.
That is super cool. So what are you here to talk about at CppCon today?
So what I'm here to talk about is C++ for cross-platform VR.
Cool. So what's your topic? What about virtual reality you're going to discuss in your talk?
So there are lots of SDKs and operating systems you have to support. And actually you have to support a variety of languages as well. So one of the strengths of C++ is, and maybe one of the reasons it's having its kind of second renaissance at the moment, is its strength as a multi-platform language. In addition, VR is a very performance-sensitive environment. So simulator sickness, which is the nausea that you feel inside of VR, is non-trivially related to latency. And if you have any latency or any significant latency as your head moves around, people get sick. So performance is a kind of key consideration. So the combination of wide reach across platforms and tight control over performance is one of the reasons that C++ is particularly well suited to this task.
Awesome. So when we have a bug, it usually just annoys developers. But if you have a bug, it actually makes them throw up.
Yeah, that's right. So the stakes are higher. With most apps or games. If you see a glitch or if things are a little bit slow, you might get annoyed and kind of curse at your phone. In this case, you might actually just feel physically ill.
That is amazing. All right. So come to your talk so that we can not feel physically ill when we write virtual reality games. That is a heck of an elevator pitch.
That's right.
All right. Do you have a tip or a trick for C++ that you'd like to share with the community?
Yeah. So given that one of the themes of the talk is cross-platform development, the tip or trick is to consider, rather than using if-defs to have specific sections of platform-specific code, instead have different translation units. It's a much cleaner way, just looking at the code itself to deal with it, and I think it's ultimately a better way to reason about it.
So it effectively pushes the if-def into the build system instead.
That's exactly right, yeah.
Okay, great. Thank you very much.
I'm John Wyman. I am a lead developer at Thomson Reuters working on Ultratext.
And my name is Kevin Kostrzewa, and I'm a software architect for Thomson Reuters for Ultratext as well.
Awesome. So I assume you're talking about how to do your taxes better as a developer today. Is that no?
Absolutely.
Okay.
Yes. It's all about taxes because that's what we want.
That's
to
how to
talk
pack
about.
them in.
That's how everybody wants to know.
What's your actual talk's elevator pitch?
Yeah.
Well, the topic of our presentation is going to be organizational leadership with modern C++. And the idea is basically when we came here last year, we were totally jazzed up with all the new things that we'd learned. And
like modern C++ things?
Absolutely.
Yeah,
Absolutely.
yeah.
The
There's a lot of super technical language nuance detail that was put out. The difference between the relevance of auto versus versus decal type and et cetera, et cetera.
And what really came to us was that well, great, now we know this, and now it's our responsibility to bring this back to our development organization and make sure that as many people are aware of this as possible.
So it's sort of how to roll that out to your organization?
Yes, and we've got approximately 75 developers in our organization of a variety of skill levels, some junior, some very seasoned veterans. And the question is, how can we roll this information out to them in a way that makes it relevant to their day-to-day work.
All right, great. Do you guys have a tip or trick for C++ you want to share with the audience?
Yeah,
Kevin?
The only thing that really comes to mind has been kind of a maxim that I have tried to do through my career as a programmer. Is none of this is magic. It's just code at every level. It's just code. You can dig down to the assembly. You can find out how stuff works. It's not magic.
Got it. So if you're looking for a case study of how to roll out modern C++ into your organization, this is the talk for you.
My name is Roland Bock. I'm head of development at PPro Financial Limited. I'm also the author of SQL 11, and my newest project is KISS templates.
So what's a KISS template?
Well, KISS stands for Keep It Simple, Stupid.
Okay.
And the background of this name is that most template engines, at least those that I know of in C++, are either too complicated to use, at least from my point of view, and or they are not statically checked. So and every error that occurs, which is not statically checked, occurs at runtime. So you get, for instance, in web environments, you get those 500 internal server errors.
I see.
And I don't want those.
Right.
So I want to prevent those as much as possible.
Great. And I think you actually have 2 talks today, right? 2 talks
Right.
at the conference.
2 talks at the conference, not today.
Okay.
The second talk is about reducing the amount of template error messages in your own template code. So it's not about filtering template error messages out, but it's so out from the compiler output, but it's about reducing them at the source, that is your own code. So I'm going to show a bunch of methods of how to basically help the compiler to generate reasonable messages.
Got it. So you basically improve your code in order to get better template messages when
Yes,
you use this
yeah.
technique.
So I did this for my own library, so for SQL 11 very extensively. So I reduced error messages in many examples from several kilobytes down to just a few lines.
Oh, awesome.
And I'm going to show these methods and give tips of how to do this in general.
Okay, do you have a quick tip for the audience?
Well, a quick tip in general would be to rely more on the compiler, use the compiler's abilities to be a dreadful nitpicker, because many people hate the compiler for that, but in reality it's a powerful tool, and you can use this ability to get compile time errors in contrast to runtime errors, and nobody wants runtime errors.
Okay, so let your compiler do its job.
Yes.
Thanks for your time, Roland.
Yeah, you're welcome.
Nice.
Thanks.
I'm Pedro Ramalhete. I work at Cisco in Switzerland.
Oh, cool.
And basically what I do in my free time and part of my work time is to develop lock-free and data-free data structures. And we also do some locks, synchronization mechanisms in general, reader-writer locks. We design that kind of stuff.
So you're like Mr. Concurrency at Cisco.
Yes,
Okay.
yes, I am. I even have a series of talks inside Cisco where I talk just about that. And I say we because I do most of this work with my wife, even though she doesn't work at Cisco, but we kind of have a kind of collaboration.
Ah, that's awesome.
So we do this together, so it's kind of our hobby and part of our job.
Got it. So is your talk also about concurrency?
Yes, it's really very focused about concurrency. I'm going to cover how to do your data structures weight-free, so what is for reads. So what this means is that you can take any data structure you want from the STL, a single-threaded data structure, you place it inside a thing called the left-right, which is something we discovered.
Left-right, like?
Yeah, left-right.
and
It's
right, okay.
left and right. It's called left-right because you have to use 2 instances, and we call it the left instance and the right instance.
Okay.
So it's kind of like a
Red,
double...
black tree kind of concept.
No, it's more kind of like a double buffering in computer
okay.
graphics.
Sure.
It's like you're drawing in one while the other one is being shown to the readers.
I see.
And then you swap them at some point, and then you do the drawing on the other one. So that's the basic idea. And of course, you have to use atomics and the new memory model to get there, and especially tricky algorithm. But it's really easy to implement. Anybody can use this. And it's even easier to use once it's implemented.
So do you provide a library that people can then include in their code for the left-right?
It's not even worth the library. You just copy-paste the code because it's just 20 lines of code.
I can see.
And then you can wrap your stud map or stud linked list, whatever you want to do with that. And you get weight-free reads operations. The write operations will be blocking, just like on a reader-writer lock. You know.
Got it.
So this is the really big advantage. And to show why this is important, I'm going to spend a big part of the presentation explaining what are progress conditions, what is weight-free.
What conditions are?
Progress conditions.
Progress
so
conditions.
That's the name we give to lock-free, wait-free, and blocking. How to distinguish these three. How to distinguish starvation freedom, which is a property inside blocking, which is very important for latency. If you're interested in low latency, which we are at Cisco, of course.
Got it.
This is a very interesting property. And then the most interesting of all is wait-free, because then all threads get to do work and complete.
Great. Do you have a tip or a trick for us?
Yes, it's a tricky one. If you have a method where you have a lot of atomic loads and stores, usually people use the default memory model, which is sequentially consistent. But if you can replace most of these with acquire and release. And the trick is, if you have, let's say, two atomic loads, the second one can be replaced with an acquire. And if you have two releases, the first one can be replaced with a memory order release. Sorry, I said stores. If you have two stores, you can replace that with a memory order release. And you can do this because memory order is sequentially consistent. None of the atomics are going to be reordered. So you want to have that kind of, let's say, that guarantee all the time, right? But if you replace the loads with memory order acquire and the stores with memory order release, there is one case where they can be reordered. And the case is if you have a store and a load. So those can be reordered. So as long as you don't replace the sequentially consistent with acquire,
that sort of guarantee
you have to
without
get
having
the,
to
so you
rely.
can replace all the other ones and it will be fine. And you get a lot of performance advantage because replacing a sequentially consistent store with a memory order release means that you don't do mfence on x86, which is a very expensive operation.
All right. So that's great. Thank you for your time.
Thank you.
Hi, I'm Lawrence Crowl. I've been on the C++ committee for many years now, and it's been an interesting journey.
Cool. And so what's your talk about this year at CppCon?
This year I'm talking about how comparison can fail you, so that if the comparisons are not well done, not well defined, you'll end up finding standard algorithms failing in strange ways.
Can you give me an example?
Well, for instance, if you use floating point, if a NAND sneaks into the floating point values, it can totally destroy your sort. And so you don't want that to happen. And in many cases, since they're so rare, you might get a bug and never figure out what it was, but it might have been that.
Got it. So someone watching this talk will learn how to avoid common errors in comparisons. Is that the best way to kind of summarize?
It's sort of like, how do you build up from the bottom to avoid the problem in the first place?
So it's kind of like computer science fundamentals. Is that
exactly? You know, there's a definition in the standard that says if you use sort, you must meet these requirements. And most people look at those requirements and say, I have no clue, and move on.
Or have never read the standard.
Or have never read the standard. And the problem is that if you don't meet those standards, and it's easy to not meet those requirements, then you're going to get failures.
Okay. And so is this in any kind of code then, not just floating point? And
it basically anything that uses comparison, sort, memoization. You know, if you've got a comparison, there's a good chance there's a latent failure somewhere in your code.
Okay, great. All right. So that will be Lawrence Crowl. Thank you very much.
Thank you.
My name is Vittorio. I am a computer science student from the University of Messina in Italy. And I do C++ mostly for hobby. I don't have a company where I work with C++, but whenever I have free time, I like to develop games and work on my libraries and other open source projects. What I am doing right now is working on a series of tutorials, video tutorials on my YouTube channel that were very well received by the community, and I hope I can help the community further with my talks and other video tutorials in the future.
That's great. You should give us the link and then we can put it
Yeah, sure.
All right, great. So you've got two talks. What's your first talk that you're going to be talking about?
So my first talk is going to be the implementation of an entity component system using modern C++ 14. And that's basically a step-by-step talk that shows in a form of a tutorial how to implement a component system, which is a way of dealing with entities and objects using composition instead of inheritance, which is something that's used traditionally. So I'm trying to let people know this other more data-oriented method and approach to programming, where you think about data as small pieces of data or logic, which are called components, and you basically create your object and your entities by combining many small pieces together. And the good thing about the talk is it's in the same format as last year. It's going to be a series of sequential code segments that will show the evolution of the code and basically guide the audience through the process of implementing the framework themselves. So you see the train of thought behind the whole process.
Great. So it's sort of a case study in principles that you can apply.
Yeah,
to
it's
adopt a component-based.
it is a case study. It's actually going to show the implementation of a small game, first using a traditional object-oriented approach, and then the re-implementation of the game using the component-based approach. So you can see the difference in how you have to think while you code in the different approaches.
It sounds really interesting. What's the second talk?
So the second talk is a 30 minutes talk about a code snippet that was posted by Sean Parent on Twitter, which is for each argument. And this code snippet is very, very powerful, and I'm going to show you how it works because it's very cryptic, and also going to show some use cases of the code snippet. And if there's time, we're going to go with a more generic version of the code snippet, and also take a look at C++17's upcoming fold expressions, which are a new feature of the language.
Fold expressions?
Fold expressions, yeah. Okay. That they will replace, they will fulfill the need that this code segment fulfilled in the past. So we're going to see the evolution of the language and how fold expression makes everything easier.
Awesome. All right. Great to meet you, Vittorio.
Thank you.
My name is Jon Lakos. I work at Bloomberg. I am here to give a talk, and I am also on the Standards Committee where we're meeting next month to do some interesting work.
Cool. Can you tell us a little bit about what your talk is and who should go and see your talk?
Okay, sure. One of the things that we've noticed is that we want to write focused software on specific topics, and there are certain categories, class categories, that are particularly important. Perhaps the most important one is that which addresses the notion of value. And not every class tries to do that, but value types are a very important category, and so we're going to explore some of the properties of value types, and it will turn out that it's not as simple as one might think. This, by the way, is the first opportunity I've had to give the talk since I interviewed Alexander Stepanov, who wrote a book back in 2008 on a similar topic. It took me many years to get up the courage to actually read the first book because it's fairly dense, to say the least. I got through about a page and a half of chapter 1 before sort of keeping it in my briefcase for 3 years, and then I was invited to do this interview, so I wound up having to read it front to back, and then his second book, both of which are outstanding, but really reinforce some of the ideas that are going to be presented coming from a totally different perspective.
Great. And anything else interesting going on in the Standards Committee regarding your work?
Sure. Actually, there are two things that I've been doing in the Standards Committee, one for a very long time, which is allocators, memory allocators. And there's always been a little bit of question as to, is it really worth complicating the standard with something that not so many people use? And after a while, there was some question as well, do they really make a difference in terms of performance? Back in April, we submitted the first version of a paper that quantifies how important allocators can be when it comes to improving performance in large systems or even medium-sized ones that are long-running. And that was fairly successful, but we didn't have enough time to explain the voluminous data that we collected. So over the summer, we collected 10 times more data and are now explaining it using color-coded heat maps. If you're interested in how important allocators could be to you, I strongly suggest that you get hold of this paper and take a look at it. It'll be out about the beginning of October.
Okay, great. So if you'll send us the link to that, and we'll put it in the comments at the bottom of this so that people can get a quick link to see that paper.
And the other one, there is another paper which is not really done, but this has to do with the notion of putting preconditions, possibly postconditions, into the standard, which we haven't had before. Doing that kind of thing is particularly important, but also it's particularly dangerous. We don't want to complicate the interfaces to the point where they look like programs themselves. So we have a group of people, and Bjorn Strustrup himself is very interested in having us all agree on something that we can all live with. And this is quite an example of design by committee, I must say.
And so this is contracts.
This is contracts. Yes, contract assertions in the interface of C++ declarations.
Awesome. Thank you, John, for your time.
All right, you're very welcome.
My name is Michael VanLoon. I'm a principal software engineer at F5 Networks and a long-time C++ user.
Okay, great. So what's your talk on at CppCon?
Well, I'm talking about STL algorithms and what they are, why you should use them. I was asked, if I had any special tips and tricks to share those, but the cool thing is the algorithms are the tips and tricks.
Just actually use them.
Right, because there's so much code. It's just loops, explicit writing out code, things that are easy to get wrong, and the algorithms are already written for you. They're already debugged, and you can apply them without having to explicitly write loops. You can do one-liners, and you get some really cool stuff that might be hard to do, And so, yeah, I do have some tips and tricks in my presentation. They're not mine. One of them's Scott Myers, one of them's Sean Parent. But both of these guys have spoken really at length also about the power of using algorithms instead of writing more code, because less code means less bugs.
Got it. So is your talk basically a case study then of how to take one and evolve it into the...
No, and it's a good question because I'm writing a book. And it's on STL algorithms. And it basically it's just, here they are. You probably never thought about them that much. This one does that, this one does this. Here's how you can use it.
Increasing your fluency for using the STL algorithm.
Yeah, because if you haven't ever thought about it before, it's like, oh, you can apply it like that. Well, well, how else does it work? Oh, yeah, okay, I see now.
Okay, great. So if you're interested in seeing STL algorithms in action, then check out Michael's talk. All right. Thanks, Michael.
Thank you.
Awesome.
I'm Jeff Bastien. I work on Chrome for Google, and I mainly work on portable native client as well as more recently WebAssembly. So what we do is we bring native code to the web, mostly C++. And my talk this week is about C++ on the web, ponies for developers without pointing users.
Oh, so I love ponies. So
yeah, of course,
that's awesome.
Of course. So the goal is to kind of showcase some of what you can do, some applications that actually work very well on the web, kind of feature what's going to come up in the future, because we've been working very closely with other browser vendors to make that a thing that just any browser supports very well, and then kind of showcase how the security is implemented within the browsers to kind of convince you that we're not kind of completely mad by shipping C++ in a browser, right? Just letting any web page run anything. And then hopefully it's kind of a bag of tricks that we have that you can use for securing your own applications.
Got it. So who's the ideal audience for your talk? Who should be watching your talk?
Yeah. So it's a bit tricky, right? Because the product that we ship within the browser is aimed at people who want to, ship C++ on the web. They have code that exists. They don't necessarily want to use JavaScript. I'm not a JavaScript hater, but other languages exist. It's nice, especially for
C++
game
conference, man. We can say it.
Exactly.
We like C++ better. All right.
But especially for like game developers or people who do scientific computing, it's kind of nice to be able to target the web because it just works everywhere, right? So that's one of the audiences. But then if you're interested in security or just you're curious about how browsers actually keep you secure, I'm going to try to touch on that too. So I think there's a bit of interest for different types of audiences there.
And what about portability, for instance?
Yeah, so browsers just kind of work everywhere, right? You have it on your phone. Usually phones have ARM processors. Desktops have more x86 processors. And honestly, so the V8 engine that runs JavaScript inside Chrome, it can support 9 architectures, right now. So really that's a key point. And what's difficult with C++ is usually you compile it once and it targets one specific architecture. And what we're doing is a bit different, where you compile your application once, but it can run on multiple architectures. So portability is a big thing, and then browsers have different APIs and stuff, especially when you're doing graphics or when you're doing file I/O or things like that. So there are kind of a few gotchas, and we try to paper over them, but it's kind of an interesting landscape there.
Cool. Did you have like a tip or a trick that you wanted to share for C++?
Yeah, so another one of my hobbies is to make concurrency and parallelism very fast, mainly because within browsers, portability is a big thing, and writing fast code for x86 versus ARM is completely different in a lot of cases. So as part of the C++ Standards Committee, C++ 11 standardized atomics, and that goes a long way to give you portability, right? Like, so your code that used to have inline assembly now can have atomics. Now, the unfortunate thing is that a lot of people don't use atomics yet, right? Because their code just works. Exactly. So one of my goals in life is to get people to use atomics, and right now people look at atomics, it's a bit complicated, they can use it, but then they try to use it, and it's slower than inline assembly. So usually the reaction is, what gives, why is it so slow? Or it's hard to use properly, right? So one of the things that we're trying to do in the C++ Standards Committee is to make atomics much more powerful. And we're also trying to make compilers much more intelligent about using them very well, right? So, one thing I did recently is I wrote kind of an interesting paper entitled "No Sane Compiler Would Optimize Atomics," and mainly the paper came out of me coming up with this title, "No Sane Compiler Would Optimize Atomics," and the abstract, which is just false. So that upset a few people because the target audience for that paper is hardware manufacturers, people in the Standards Committee, and then developers who may want to use it. And the paper kind of goes into things that are a bit surprising to the three audiences, right? So as parts of the Standards Committee, it was like, wait, what? This is what we standardized? How? I didn't know this, right? Whereas the hardware vendors are kind of interested because it allows them to showcase their platform's capabilities much better. So they're interested, but they're not necessarily aware of everything that the language does yet. And for developers, it's kind of interesting. There's a lot of clever tricks you can pull when you do that type of computation. And ideally, it's the type of stuff that you have in the library, so you don't really have to think about it too much, right? But still a really interesting topic.
For somebody who is like you said, your mission is to try to get people to use atomics. What
Correct.
is the best resource for people who want to just sort of learn about it and start to incorporate it into their own code?
Yeah, that's actually really difficult.
Probably not just read the standard.
Yeah.
Right?
Well, if you read the standard, it's actually not quite clear what you can use. It's not clear, for example, that consume atomics in the standard are completely broken. No compiler actually implements consume. And if you look at CppCon this week, Paul McKenney has a talk about how he's trying to fix consume, right? So Paul works at IBM, and IBM is one of the biggest the architectures that can gain the most from consume being a thing.
I see.
So Power as well as ARM can do really clever tricks with consume. Unfortunately, you can't use it within C++. And so if you look at the C kernel uses effectively consume semantics the Linux kernel. It uses consume semantics extensively without any language support for it. So right now it's really, really hard to figure out how to use atomics, right? Like the best thing I can say is just use a mutex or use a data structure that does the right thing. But there are parallel extensions to C++ that are kind of slowly making their way to C++, maybe in C++ 17. And those kind of give you the best power. So if you look at the Trust library that is effectively being standardized as the parallel extensions, that one is super interesting because it just works for you, right? And under the hood, it uses atomics, but it means that for my type of application, the one that runs inside a browser, the user just uses code and it works, right? So most developers shouldn't use atomics. Most developers are interested in it, right? It's like this quirky thing, but yeah,
library, basically.
Exactly. So I hope that over time we can evolve the language to be kind of easier to use and to have more capabilities with libraries to make that easy. But at the very lower level, it'd be really great if everything just kind of worked really well. And we're not quite there yet.
All right, but we're working on it.
Yes.
Awesome. It was great talking to you.
Yeah, thanks
for dropping by.
I am Juanpe. I'm a software engineer currently based in Berlin. I work for Ableton, which is a music software company. And yeah, I came here to CppCon to talk about transducers, which is a construct that was invented for Clojure, which is a functional language.
Oh, okay.
And that we found actually that can be translated elegantly also to C++. And what this construct allows you to do is to express transformations over sequential processes. One example would be an iterator, right? Which is the most simple sequential process you can have. But not only that, also like a boost signal, for example, could be considered a sequential process, or an RX or observable, like something that actually emits.
Or even like yield return in the new await.
Yeah, exactly. Yeah. All those things actually that kind of produce values, even though they are not necessarily in memory all the time, right? Like,
Got it.
Like the different values happen over time, which will fit in a more like push model, right? You could think of. All these things can be transformed with transducers because they are expressed in a way that is independent of what's the source of the values that are being processed.
Okay, and so in your talk, you'll talk about like what transducers are, and also how to apply them in your own code?
Exactly. So the idea is to talk about first what this concept is, basically, and where it comes from, closure, as I just said, and so on. But also how the implementation works in C++, right? Because C++ is not closure, so there are some differences in how you will treat them, and then how to also apply them to your code, of course.
And is it like basically a library that you can include that helps to add this support?
Yeah, so this is it's all the source code is available in a library called Atria that we developed at Ableton.
Oh, great.
And that is open source under, I think, MIT license.
Okay.
So, yeah.
And you can send us a link and we can include it with the video.
Yeah, for sure.
Okay, great. Thank you very much for your time.
Well, thank you.
I'm Brett Hall. I work for a company called Wyatt Technology. We build scientific instruments that are mainly used in biotech and pharmaceutical research.
Cool.
I'm the lead engineer on one of our data analysis, data collection packages called Dynamics. And I'm speaking specifically about the software transactional memory system we use in Dynamics. We've been using it for about 5 years now.
Okay, tell us a little bit about transactional memory.
It's a system basically for doing shared memory concurrency, not using mutexes. It's sort of a replacement for mutexes that avoids the problems with deadlock and that sort of thing. Basically, you start a transaction, and then everything you do in that transaction should behave like it's isolated from the rest of the system. Any other threads that are running, you don't have to worry about that.
Until it gets committed.
When it gets committed, well, it sort of depends on how it's implemented. It could be implemented in a way, like the most brain dead way would be just to have a global lock and only have one transaction running at a time. You're not going to do that because that's going to have horrible performance. Most of them you get to the end and they have to do a consistency check and then roll back if something changed. But basically the base definition is that it just behaves like it's the only thing running during the transaction.
So is your talk sort of a case study of how you applied these techniques in your own code, or is it?
It's a little of that, and well, first off, I have to define what it is and explain what it is, because no one uses it yet. And so I get into that. I get into what our system looks like, because we created our own system. I also get in a little bit, there's study group 5 of the ISO committee, that's also working on adding it to the standard. They have a new technical specification that they just voted out at the last meeting. So I get into a little bit of what that looks like, and then basically what our experience was, what pitfalls we hit, that sort of thing.
Great. So if people are interested in learning more about transactional memory or actually seeing how it was applied in your domain, that this would be the talk for them.
Definitely.
Okay, great. Thanks, Brett.
My name is Viktor. I work for Zeptolab, and we create computer games. And I'm here to talk about some ideas relating to modern C++.
Great. So I think you have actually 2 talks at the
That's
convention.
True. Yeah.
So talk me through your first one, STL containers.
Yeah, the first talk is about STL containers. The fact is that many companies, when they want to develop some effective program, what they do is they firstly implement their containers. And if you take a look at different source code bases, you will find that almost nearly everyone has their own implementation of containers. And so we do. Because standard library doesn't contain all the features that are required in object-oriented programming.
Got it.
And I'll be talking about some ideas related to common implementation of general things that are required to almost everyone who create object-oriented programs.
I see. And so would somebody watch this talk if they wanted to learn about techniques for applying the STL containers or expanding the STL containers, or is it more about what would go into the standard at a future point? Or
Well, I don't know if there are any plans about expanding the standard currently, but there are some ideas that almost anyone share. And I think that the next step for C++ standard could be like adding some containers or adding some wrappers for standard library containers to provide functionality that people want.
Great. And what's your second talk topic?
And the second topic is about properties for C++. As many people know, C++ doesn't have properties. A property is a thing that is in the middle of a class field and a class method. And property allows to overload assignment operator like that. And if you have a big code base, then probably properties is what you need. And I'll talk briefly about my implementation of properties because what I could find on the internet isn't very efficient.
Got it.
I think that we could find with the audience the most efficient way to implement properties and make it available for the whole C++ society. So probably, I hope so, it could be like a general piece of Scott Meyers like that. So how to implement properties efficiently.
Great. All right. It was great talking to you, Viktor.
I'm Sumant Tambe. I work for Real-Time Innovations in California. I've been Microsoft C++ MVP for a couple of years now. So thank you, Microsoft, for that. In Real-Time Innovations, RTI, I work on sort of the intersection of industrial IoT systems, and my work tends to be more research on how to use data distribution service for applications, stream processing applications. That's what my talk was about. I also would like to talk about a library, actually a couple of libraries I've been working on, Reflex and Reactive. Both are libraries that allow you to do powerful, like much more expressive declarative style. I think that's what I was referring to. Instead of imperative style, you could use declarative style for programming. So that's what I'm working on these days.
Got it. What's the topic of the talk that you give?
Yeah. So what I meant when I mentioned it's this reactive programming in industrial IoT, you have really 50 billion devices that are expected to be connected, right? And you have to have some processing at the edge because there's so much data.
I see.
Yeah, it does not have to be in cloud. It will not be in the cloud. It will be at the edge. So you need some sort of stream processing over there, which does not have powerful data centers. So this library, open source library called RxCpp, is an implementation of the Rx programming model that allows you to write CEP, complex event processing style programs, right in C++. You can do it in many other languages. So it is open source, really powerful. So I would encourage everybody to look at this, look at the talk. I have 3 demonstrations in it, of stream processing. So I hope it will be fun to watch.
Okay, great. And if you send us the links, we can put down like where to get the open source library, and I'll put a link into
Absolutely.
your talk.
Yep, sure, can do that.
And did you have any tips or tricks you wanted to share?
Sure. So I would like to suggest that if you have any category theory friends, category theory friends, then I think this would be a good time to start. If you come across one, be nice to them. Or if you are one of those, if you are a category theory person who is really into functional programming, monads, and those kind of things, I think those things are coming to C++. You like it or not. Async libraries.
Was that a threat? No, I'm just kidding.
Depending upon what you are taking is on functional programming in C++. So Eric's ranges library.
Yeah,
then RxCpp, reactive programming model, futures, and then expected. I think that's expected E, which is error or type T. All these things are essentially monads. Whether you like them or not, they are going to be there in C++. So it's time to be friends with category theory.
Friends with functional programming.
That's right.
Got it.
Yeah.
All right, great.
Yeah.
Thank you very much.
Thank you.
All right, so that was the interviews. There should be links to all of the talks of the people that we talked with, and sometimes even to their libraries that they were discussing in the description. Gabby, tell us about next time.
Well, next time we'll talk about what happened at the Corner Standards meeting. That was last week. I came back about 2 days ago. Sorry.
He's tired. It's rough there in Hawaii.
So next episode will be about the C+ Standards meeting that happened in Kona, Hawaii last week. A lot of things happened for C++ 17. We'll talk about modules, contracts, coroutines, and a lot of stuff going in library. In particular, the parallelism technical specification will be in C++ 17. See you next month.